Hello friends! Today I'm doing a tutorial in Unity on how you might implement sensors into your game. Now if you're not already familiar, what a sensor is a mechanism by which an object is able to determine if there is another object near it. And this is a very useful concept for being able to make it so that collectible objects will move towards the player when they get nearby, triggering when to open a door when a player gets near it, or really just any of a myriad of different things that you might want to be doing. So for the purposes of our demonstration here and what we're going to be coding today, we have this very simple scene here where we have a little sphere is going to be our player that is going to roll around. And we have these floating cubes are going to be sort of like warning lights that are going to turn red when the player gets near them. Now a demonstration is worth its weight in words, so let's just play the scene and see what it looks like. So we can already see that as soon as we spawn, this light is turned red because the player is close to it, and these other ones are green. Now, as the player starts rolling forwards, this other light is going to turn red, the one behind will turn green, and so on and so forth, and they do respond to stimuli as you get nearer or further away from them. Now, before we commit to writing any code, it's important to have sort of a plan of attack or design so that we can keep our thoughts organized while we're creating. I like to begin with our player because that's what the person sitting behind the keyboard is going to be interacting with, and I find it important to make sure that this is correct before we do anything else. Now our player is actually very simple in this demonstration. They're capable of moving both forwards and backwards. As a bonus, I'm also going to have the player destroyed after a few seconds because this is going to help demonstrate an issue that you might encounter when creating your own game with these sensors. Now our alarms are a little bit more complicated. When the player gets near a sensor, the alarm is going to turn red. And when the player moves away from the sensor, the alarm is going to turn green. Now, if the player doesn't exist, for instance, they've been destroyed, since they no longer exist, it makes sense that the alarm is going to be green. The architecture behind our proximity alarm is a little bit more complicated than our player as well. So our main object is this proximity alarm game object, which is going to have this detect player script attached to it. This script is going to be responsible for changing the color of the alarm as a response to whether or not the player is near it according to the sensor. As a child of the proximity alarm, we also have another game object, which is an area of effect. This area of effect is going to have the sensor script attached to it, and that script is where the magic will happen in determining if a player is near it. It's able to do this thanks to a collider that we're going to set onto the area of effect. This collider will have to be in a triggerable state because it's not going to have any physics attached to it, or else you'd get some really strange behavior as a result. Alrighty, so now that we have our design out of the way, we might as well get started on actually writing some code and putting our game together. So I have a brand new scene here, and I already have a couple of folders set up in the style that Unity seems to be preferred here. And well, let's just get to it. So first off, I'm going to create some terrain basically for us to interact with. I'm going to call this my grass. And if I view it from the game, it's a sort of awful beige color, which honestly does actually look like my lawn right now. But you know, I would like to have a nice greener color. So I'm going to create a few materials here. So here's my first material. I'm going to call this one grass. Grass is going to be green because that makes me happier. Whoops. And I can go ahead and take my grass and I can drag this material right into my mesh renderer, and it's going to give us this nicer, darker color that is just much more lovely than that beige. While I'm in the habit of creating materials, I might as well create a couple more for our proximity alarm, which is going to be changing colors as our player gets near it. So I'm going to start with a red one. Now red's going to be pretty easy, it's just going to be red. And I'm going to go ahead and create another material here. This one's going to be green. And this is just going to be a nice, bright neon green. Okay, so with that out of the way, we might as well get started by creating our player. So our player is going to be a sphere, and I am going to make it a little bit smaller than the default here in every direction. Let's put it a little bit closer to our camera here. That looks pretty good. Kind of a hard time moving the camera around. That looks pretty good to me. Although our camera isn't exactly where I would like it. So let's start by bringing this up a little bit and tilting it down to take a look here. And gosh, this doesn't look very centered to me. Let's just bring that over. Perfect. Okay, that looks much better. Okay, so now that we have our player is positioned, I guess we should do a little bit of our odds and ends here. So I'm going to start by naming this object player because that makes sense to me. I'm also going to give it the player tag, and this tag is important because it's what our sensor is going to be using to determine if an object that is near it is actually the one that it's looking for and not just some random other object. With that all done, I should start by attaching a script to my player. I'm going to create a new C# script. This is going to be the one that is going to allow it to move, so I'm naming it player movement. And now there is like a million different ways that you can make your player move, and it's not really the focus of this tutorial, so I'm just going to make it quick here. So I'm going to create a rigid body. I'm also going to serialize a field, which is going to be our speed. Now, what serializing the field does is it makes it visible inside of the inspector, in case you weren't already aware. It's very similar to making a public variable, except it still keeps the private status on it. So that means that no other scripts can interact with this player movement speed. It just makes it a little bit more secure. It makes your code a little bit cleaner. So to start our scene off, we want to get a rigid body, and we want to actually get it from our player. And saying that, it occurs to me that I have not actually attached a rigid body to our player yet. So I will go ahead, grab that now. Rigid body, just the default settings is probably fine here. And while I'm back in the inspector anyway, I might as well go grab this player movement script and attach it like so. So we have a rigid body now, we have our speed, perfect. So that's everything that we should need. I want to get some input from the player, so I'm going to capture that inside of this float here. I'm calling it forward input, and I'm going to get that by getting an axis from the input manager. This one is called vertical because I'm going to use the forward and back keys in order to make it move. And this is going to give me a number between -1 and 1, which I can use to tell if I'm moving forwards or backwards. So now that I have all that, I can take my rigid body and I can apply a force to it. I'm going to apply the force in the forward direction. I'm going to multiply it by my speed, and then I'm going to multiply it by the direction that the player is actually pushing in. Alright, so we save all that. Life is good. And we can move back to our inspector. This should reload shortly, and I put in my speed. I'm going to give, I think 10 is probably okay. I'm going to run the scene, and yeah, that looks pretty good. He's able to move forwards and backwards. And that's basically as far as we need to go with the player. So we can start on the proximity alarm. These ones I'm going to have as cubes. I'm going to call this the proximity alarm. And I'm going to change its scale. 0.25, 0.25, 0.25 is probably a good size. I can't actually see it. It came up. Wow, that's pretty low. All right, so yeah, that should probably be fine. Now, because I'm going to be creating a few of these in the scene, I'm going to go ahead and make it a prefab. So I'm going to just dump that in here, and this is my proximity alarm. Now, this alarm is going to need a couple of scripts attached to it. So first off, I'm going to open up the prefab, and now I'm going to create a new script, which I am going to call, let's see, I'm going to need two, according to my design. I'm going to have a detect player, and I'm going to create another one, and this is going to be called my sensor. I might as well start setting that up too. So I'm going to create a new empty here, and I'm going to call this my area of effect. Now the area of effect has nothing attached to it right now, which is perfect. That's exactly what I want. So I am going to give it, I think I'm going to use a capsule collider, but really you can use any collider for this. And I'm trying to remember what I used as my height before. I think, well, it doesn't really matter how high it is as long as it touches the ground. And I think maybe an 8, that might be good. Let's take a look here. Yeah, so that is the area that if a player runs into it, they're going to end up triggering the sensor. So I'm going to put this one a little closer to the player just to start. So the player starts inside of the zone of influence here. Perfect. Okay, so I'll go back into my prefab. I have my area of effect. It has my collider on it. And it is very important that I trigger this is trigger box. So as long as that box is checked, there's no physics that applies to this collider. If that box isn't checked and our player runs into this object, it's going to actually basically bounce off of it. It's going to act as if it is a solid object, and that's not really what we want here. I can go ahead and add my sensor component as well. So I might as well jump into that script because it makes a lot of sense for me to start here. And let's see, so there's a couple variables that I'm going to need to keep track of here. To start with, I am going to need to get my collider. So I'm going to have my collider. I'm going to call this my lowercase sensor. And I'm going to start by getting my sensor. I'm just going to be get components, sensor. Nope, that's not correct. I want to get my collider. Okay, now because we clicked that that trigger box, that is trigger inside of the inspector, we're going to be able to use a couple of additional Unity functions that we have on model behaviors, and those are going to be called on trigger enter, as well as on trigger exit. And Visual Studio is pretty nice to me; it just automatically completes those for me, so they're all ready to go for us. There is one more thing that I'm going to want in here. So this one is going to be a public boolean that is going to be is detected. Is detecting. This is going to be whether or not it is able to, whether or not a player is near it, essentially. So I'm going to start with the on trigger enter code here. So when any object enters into the triggerable area, enters into the collider, it's going to give us that object that entered this collider so that we can do something with it. So what I'm going to do right now is I'm going to check to see if other.compare tag is equal to, oh, I knew I forgot something. I need to know what kind of tag we're looking for. So I could go ahead and just say player in here, and that would be totally fine. Something else that you might want to do so that you can use these sensors in more places, though, is you could make a serialized field here, which is going to be a string, and I'm going to call that tag. And we can actually just say, right in our inspector, oh, did not mean to delete that. You can say right in our inspector what tag we want to look for, so you just say tag right there. So what this is checking is to see if the tag that we have set is equal to the tag on the object that has entered our collider. And if that's the case, then that means that the thing that we're looking for is here. So we can say is detecting is true. Let's see, so we also want to do the opposite behavior in here. So we can say other.compare tag equal to tag. We can say is detecting equals false. Okay, and that's basically all that we need to do on our sensor. That is the lion's share of the work right there. So I'm going to go back into my inspector. I've saved my script, so it's going to reload here. I'm going to call this player. So it is going to go find the player object when something happens. And unfortunately, I don't actually have anything that I can really demonstrate right here because no behavior has actually been attached to the sensor. It is just checking to see if something is near it. But I can go into my proximity alarm. I can attach the detect player script while I'm in here. Come on, get in there. There we go. And I can go ahead and edit this now. So first and foremost, I know that I'm going to have two different colors that I might want to apply to myself. So I'm going to serialize a couple of fields, and they are going to be materials, and I'm going to call this one alarm, and I'm going to serialize a field. It's another material, and I'm going to call this one all clear. Which, save those. I'll go into my inspector again, and these are available to me now. I'll go into my materials. Oops, that's the wrong one. Proximity alarm. So for all clear, I want to be green, and when I'm raising the alarm, I want to be red. That makes a lot of sense to me. go back into our script, and I want to be able to change the color. So in order to do that, if I take a look at where we have our materials, they're attached to our mesh renderer right there, and I could change the color of it right now by just dropping it in there. So that means I can change its color by going into the script by saying, let's see, I need to get my mesh renderer, and I'm just going to call this one renderer, and I'm going to get component, oh heck, for mesh renderer. Oh, and I do want to save that inside my renderer. There we go. Okay. Let's see. I also need my sensor too. That's a pretty important part of all of this. So I'm going to call this sensor. And sensor right now is a child of me. So I can use the get component in children method, similar to how you use get component. Look for a sensor here. There we go, and that should pick it up. And then on update, I am going to grab if sensor dot is detecting, which is our public variable. So because it's public, we're able to use it inside of the script. Then I'm going to get my renderer, and I am going to set its material to be equal to our alarm because the player is now inside of it. If the sensor is not detecting, then I can go ahead and get my renderer, set its material is going to be equal to all clear. Okay, so with that, I think we have everything we need to actually start our basic demonstration. So let's go into our scene. So we are red right now. I'm going to move away from this object, and look, it turned green. That's exactly what I wanted. Okay, that's good. In order to sort of help kind of prove that this is working, what I like to do is just grab a few more of these guys and put them around in the scene somewhere. Okay, and just see that this works. So I start close to this guy, these guys are green, and gosh, that sure looks a lot like the demonstration we did at the start. And you might think that we're done at this point, and in a technical sense we are, because in this current state, these sensors work perfectly fine. However, there is a potential issue that we might run into where our player no longer exists, and it technically does not exit the collider when it disappears and is destroyed. So it never triggers our sensor's on trigger exit event. So it will always be reading as detecting, and I'm going to demonstrate this pretty simply for you here by creating another script and attaching it to our player. I'm going to call this destroy self soon. Whoops. It's going to be a pretty simple script. You know, I don't even really need that timer in there. And I'm just going to say on start, I'm going to destroy my game object after, let's say, 5 seconds is probably a reasonable number. That is a very simple script. We grab our player, we can attach the destroy self soon script to it, and we can see, just for demonstration's sake, I'll try to get close to these two. I guess I only got close to one. And we see that the player has disappeared, but this alarm is still red. So that means that something has gone wrong. There's no player here, so we want that to turn green. So that's a problem that you might encounter when you're using these sensors. Especially if, for instance, you're making some kind of a shooter and your player is like destroyed, they just got shot. Your player no longer exists, and that's an issue. So what we can do is we can go into our sensor, and one potential solution is we grab a game object here and call this object defined. And we can say, when we enter our trigger, we can say object defined is equal to other, the object that triggered the sensor, dot game object. When we exit, we're no longer looking for this object, so we can say object defined equals, let's say null. It no longer exists. And we have to do one more thing in our update. which is to check to see if the object is destroyed. Now Unity will let you do this by saying if object defined is equal to null, and in our case we're just going to say is detecting equals false. And technically there's a little bit of duplicate logic in onTrigger exit and an update because we're setting object defined to be null, and well, it will be null inside of the update here as well. And I don't really view this as a problem because this code is very readable too. So there isn't a whole lot of confusion on what can happen here. It's a pretty expected behavior. Let's see, so with that done, I think we're covered now. I think if we go and we run this demonstration, we should see our player will destroy itself after a few seconds. And our lights turn green again because the player no longer exists. So there you go. That's basically the whole thing right here. We have our player. I'm just going to run the scene again. We have the player is able to move back and forth. These lights are going to change color as the player gets nearer and further away from them, and they're going to return to their default state when the player is destroyed. Alright, so by this point you're basically a master of the sensor right now, so you're able to determine if a player is near another object of some kind. However, if you're anything at all like me, you learn better from actually tinkering with your project and actually putting your hands on and building something rather than simply watching a video. So what I would like to do is challenge you in order to improve on this demonstration in some way. And if you don't have an idea of how you might want to do that, one suggestion that I do have here is, well, I might as well just play the scene, is I've added another color in here so that if we're somewhat close to our sensor, it's going to turn yellow. So we do change different colors here as we move along. So it still has all the original behaviors. It just has this extra one that if you're, oh, there we go, goodbye. So if we are somewhat near the sensor, it turns yellow, is basically the new thing that has been added to this demonstration. Anyhow, thank you so much for watching. What I'm going to do for you is I'm going to put the source code for this project in the description for the video just below. And if you did like this video and you found it helpful, it would do me a tremendous favor if you would just like and subscribe, and if you do use that source code, give that a like as well. Thank you again so much for watching, and we'll see you in the next one.